Dear students, welcome to college channel. In this video, we are going to see electrical circuit analysis in unit 1. So, in this video, we are going to see the introduction about basic circuit analysis. So, it consists of electrical quantities, network elements, RLC parameters, energy sources, Ohm's law, Kirchhoff laws, power in series circuit, resistors in series, resistors in parallel, mesh analysis, nodal analysis for each in this circuit. So here in electrical quantities, we are going to see what's the voltage, current, power and energy, circuit, active and passive elements of the circuit, bilateral and unilateral, linear and nonlinear network, lumped and distributed network. The voltage, it can be defined as any atom has two charges. One is the positive charges, another is the negative charges. So, if the electron move from one end to another end, the force is required. So that potential or force is known as voltage. Finally, you can conclude the voltage is defined as the force required to transfer the electron from one end to another end is known as voltage. So V are equal to dW divided by dQ. The current can be defined as the flow of free electron in a conductor or flow of electron in a conductor due to potential applied. So it can be defined as the rate of change of charge particle is known as current. Power can be defined as it's a capacity to do the work. So the unit of power can be defined as the energy with respect to time, or otherwise the rate of change of energy is known as power. The circuit is made up of three parts. One is the energy source, another is the load, next one is the connecting wires. So in this case, if the active and passive elements are present in a circuit is known as circuit. In simple manner, who are all the components provide the electric supply is known as active element. Who are all the which are the components have the electric supply is known as passive component. The combination of active and passive elements is known as circuit. So it can be four types by means of network element. One is the active or passive element, another is the unilateral or bilateral element, another is the linear and nonlinear element, and lumped or distributed element. One is the active element. If the elements are deliver the power or deliver the electrical power to the another is known as active element. Example is the voltage or current sources or battery. Passive element. The passive element can be defined as the elements which consume the energy from the active element is known as passive element. Example, resistor, inductor, capacitors. Bilateral and unilateral element. In bilateral element, if the characteristics and behavior of the particular element are same, it's irrespective of the direction of current is known as bilateral element. The example for bilateral element is a resistor, inductor, capacitor. The unilateral, the behavior and the operation depends upon the direction of current is known as unilateral element. The example for the unilateral element is diode. Linear and nonlinear element. The circuit network whose parameters and laws are constant, that's irrespective of time, voltage, temperature is known as linear network. If the parameters can be changed with respect to their value and time, temperature, voltage is known as nonlinear network. Lumped or distributed network can be defined as a network which all the circuit elements are physically separable. Means lumped network cannot be physically separable, means a distributed network. So the network elements can be classified into three types. One is the resistor, capacitor, and inductor. The resistor which has the property of resistance. That means which opposes the flow of electron or flow of current in a particular element is known as resistor. The symbol is denoted in this diagram, and the relation between the voltage and current is given by the Ohm's law. So R equal to V by I. The capacitor, two conductor can be separated by the dielectric medium is known as capacitor, which is the property of capacitance. That means which oppose the sudden change in voltage in a circuit is known as capacitor. The symbol is given in the diagram. So C equal to Q by V. The current in the capacitor can be defined as I equal to C into dV by dt. So substitute this value. The energy stored in the capacitor can be given by half CV squared. Inductor. Inductor is an element in which the energy can be stored in the form of electromagnetic field. The figure shows the symbol of the inductor. The current voltage relation is given by V equal to L into dIdt. We can rearrange the equation dA equal to half LV into dt. So the energy stored in inductor is given by W is equal to half L square. So these are the things parameters can be given: resistance parameter, capacitance parameters, and inductance parameters. According to the Ohm's law, current is directly proportional to the voltage and inversely proportional to the total resistance. So V equal to IR. So initially we are going to see resistance parameter. This can be written as V equal to R into dQ by dt or I equal to V by R. The power absorbed by the resistance is given by P is equal to V I or IR I squared R, where the current in the resistor is V voltage across the resistor volt. So WC is given by integral 0 to T P into dt. That means I squared RT. It is also known as V squared by R into T. This is a capacitance parameter. We know the value of capacitance C equal to Q by V. Similarly, the current in the capacitor I equal to C into dV by dt. From that equation, we can get dV is equal to 1 by C into I into dt. Integrating on both sides, we will get V of t is equal to 1 by C integral 0 to T I into dt plus V of 0. So power, that means energy, is given by half CV square. Similarly, the inductance parameter, we know that V is equal to L into di by dt. From the equation, we can find out dA equal to 1 by L into V into dt. Integrating on both sides, we'll get I of t. I of t is equal to 1 by L integral 0 to T V dt plus I of 0. So power is given by V into I. That is given by Li di by dt. The energy stored in inductor is given by integrating the equation P into dt. We get W is equal to half Li square. These are the parameters of R, L, that means resistance and inductance and capacitance. The remaining, that means Ohm's law, Kirchhoff law, we can see in the next video. Thank you.